Today we are doing class 9 physics. This is the second chapter, motion in one dimension, and we are doing the graphical representation. Today we will do velocity time graph. First, we know the definition of velocity. The displacement traveled by a moving body in a certain interval of time is called its velocity. Okay? In velocity time graph, we have the two axes. This is your x-axis and this is your y-axis. Here in velocity time graph, x-axis represents time in seconds and the y-axis will represent velocity in meter per second. So SI unit of velocity is a meter per second. So we are taking the velocity as meter per second. And where these two axes meet, this is called the starting point or the initial position. Initial position. Okay. And previously we have done when the body is moving away from its initial position in a particular direction, this will determine the velocity. Okay, and this slope is considered as positive slope. Okay, and as per velocity time graph, this is the positive velocity. So this is your positive velocity. And when the body is returning to its initial position, this we consider as negative slope. Negative slope. And as per velocity time graph, we will consider this as negative velocity. Okay, so we got it. When the body is moving away from its initial position in a certain direction, that is considered as positive velocity. And when the body is moving opposite direction or towards its initial position is considered as negative velocity or negative slope. Clear? And with the velocity time graph, we can determine one is displacement. Displacement of the moving body in a certain interval of time. So displacement will determine in a certain interval of time. 1 and 2 we can determine acceleration of the body at any instant. Okay, so in order to determine the displacement, we require to find the area. So suppose if we have a graph here, okay, this is your time and this is your velocity. So if the body is moving this direction, now from this point to this point, if suppose we take this as P and this position we take as Q, now we have to determine the displacement of the moving body from P to Q. So if you drop a perpendicular, we will get a right angle triangle PQR. Now if we have to determine the displacement or the distance traveled by a moving body from point P to Q, we have to find the area enclosed between the x-axis, that is the timeline, and the velocity time scales. By finding this area, we can determine the displacement of the moving body. So displacement of the moving body we will find by finding area enclosed between velocity time scales and x-axis. X-axis, or we can call time line. So whatever area enclosed in this, if you find the area, we can easily determine the displacement of the moving body. And we know the formula for the displacement. Displacement is the product of velocity and the time. So we can write here this displacement is equals to velocity into time. By finding the area enclosed between velocity time scale and x-axis, we can determine the displacement or the distance traveled by the moving body. And if you have to find the acceleration of the body at any instant, we have to find the slope of the velocity time scale. So this is the velocity time scale. By finding the slope, we can easily find the acceleration, and we know that acceleration is the increasing velocity with time, or acceleration is here. Acceleration is equals to ratio of change in velocity divided by change in time. To find the displacement, we require to find the area enclosed. You will find different kind of graph in your class. One is this, where we are finding a triangle. So here, if you see this, the body is moving this direction, and after that, for certain time, the body is moving with a constant velocity, and again the velocity of the body drops. Then the graph which we are getting is a trapezium, A, B, C, D. So area enclosed is a trapezium, and other also we find. So if you have a graph like this, if the body is moving with a constant velocity, okay, and then if you have to find the displacement of the body or the distance traveled from point A to B, from here you have to drop a perpendicular, then C, D, if you consider, we are getting rectangle. So in order to determine the displacement or the distance traveled, we have to find the area. For that, we need to know the area of at least three figures. One is a right angle triangle, trapezium, and the rectangle. Here is a right angle triangle. Okay, this is a trapezium. Okay, and this is a rectangle. Okay, I'll just write the areas. Area of one, I'm just writing triangle is equals to half into base into height. Okay, and number two, if you have to find the area of rectangle, is equal to simple length into breadth. And the third one is your trapezium is equals to half into sum of parallel sides into height. By knowing these areas, we can easily determine the distance traveled by a moving body. Okay? Velocity time graph for uniform velocity. Uniform velocity, we know that if a body travels equal distance in equal interval of time in a particular direction, then the velocity is said to be in a uniform velocity. Okay, uniform means constant, which will not change. The velocity of the body will not change. For this, we will make the graph first here. Let's take this as x-axis and this as y-axis. X-axis represents time in second, y-axis represents velocity in meter per second. We'll make this time here 1, 2, 3, 4, 5. These are the time in second. (30 meter per second, 40 meter per second, 50 meter per second. So initially, if the body is moving with velocity 30 meter per second, now we have to plot a graph for a uniform velocity. Initially, the body is at 30 meter per second. After 1 second, its speed will remain the same, 30 meter per second. After 2 seconds, again 30 meter per second. After 3 seconds, 4 seconds, 5 seconds. If you see this, the car is not changing its velocity. It is moving with the same velocity. If we join these lines, so we are getting a straight line, and we can easily see that this line is parallel to the x-axis. Velocity time graph for uniform velocity is a straight line parallel to the x-axis. Position as A, and this is a B. So here initial velocity of the body we consider as u, and the final velocity of the body we consider as v. So here u is your initial velocity and v is your final velocity. Okay, let's consider initially the time was t1 and finally the time is here t2. So t1 is considered as initial time and t2 as final time. Displacement after 5 seconds. Displacement after 5 seconds, or displacement from A to B, we can say that after 5 seconds, 5 seconds is here, we drop perpendicular from here. If you drop a perpendicular, we are getting this figure. A, B, this consider C and this consider D. A, B, C, D is a rectangle. Now by finding the area of the rectangle, we can easily find the displacement after 5 seconds. It's equals to area of rectangle A, B, C, D. Okay, this area enclosed between these two points. Area is the length into breadth. If you see here, from position here to here, AB is equals to DC, which is the length. So this length is how much? 5 seconds. AB into breadth we consider as BC, and AD is same. So it is a BC. 5 seconds into, so BC is how much here? BC is equals to AD, and AD is how much? 30 meter per second. Here also it is moving with the constant velocity, so this will be a 30 meter per second. So BC will be a 30 meter per second. So S we can have cancel. 530 times will be 53 or 15 meter. With the velocity time graph, we can determine the displacement of the body in a certain interval of time. So now if you have to calculate the displacement of the body from point P to Q, so P to Q, we have to drop a perpendicular from P and drop perpendicular from Q, and this is your PQ R S. So R is on the 4th second and S is in the second. Now if you see this, so if you measure this distance, PS is equals to QR, and this is equals to AD. It's same. This is your 30 meter per second. And if you see this time from this to this interval, and these two are equal. This side is equals to this line is equals to this line, and the interval of the second is 1. This is 2, 3, 4. So that means 1, 2 seconds. Here is a 2 seconds. With this, we can easily determine the displacement of the body from 2 to 4 seconds, or displacement of the body from P to Q. Okay, let's find this displacement of moving body from P to Q. From PQ is the area of rectangle. What is the rectangle? PQR is. PQR is. This is your PQ into QR. PQ is how much here? 2. This is your second into QR is here how much? 30. This is a meter per second. Second cancel. 2, 3 as 6. 0 meter. This is the displacement. Now the velocity time graph for velocity increasing by equal amount in each second. So here the velocity of the moving body is increasing by equal amount in each second. So if the velocity in the first second is increasing by 10 meter per second, then in the second again it will increase by 10 meter per second. So increasing velocity by equal amount in each second. I have made a table here, time in second, velocity in meter per second. In 0 second the velocity is 0, 1 second it is 10, 2 second it is 20, 3 second it is 30. See here, so that means here the velocity is increasing by equal amount in each interval of time. Here in the x-axis we have time in second, in the y-axis we have velocity in meter per second. This is your velocity, this is your time. Okay, initially when the time is 0 second, the velocity is also 0. In time 1 second, velocity is here 10 meter. So we can join this. And in 2 second, this is a 3, 4 and 5. This is a 20, 30, 40 and 50. So if we plot this point, in 1 second the body will reach here, in 2 seconds the body will reach here, in 3 seconds the body will reach here, in the 4 seconds the body will reach here, and the 5 seconds the body will reach here. Now if you join these lines, we will get a straight line, a slope. For 2 seconds it's here, 3 seconds, 4 seconds, and say this is 5 seconds. So we already learned that with the velocity time graph, one, we can determine the displacement of the moving body in certain interval of time. If by taking any two interval of time, we can easily determine the displacement, and we can also determine the acceleration with the help of this flow. Suppose if you have to find the displacement of the body after say 5 seconds is equals to displacement. If you have to find with the velocity time graph, we have to find the area enclosed between the velocity time scale and the x-axis. Here area enclosed will be this, and if you drop a perpendicular line from here, PQR. So the area of the triangle PQR will give us the displacement of the body after 5 seconds. This is a 5 seconds. So here we will write area of triangle ABC is equal, area of triangle PQR half into base into height. So here we can consider this is the base. This is our base. The base is here P into height is here QR. This is R. This is our height. Is here QR. If you see here 1 by 2, PQ is how much? This is 5 seconds in the x-axis. This is here 5 seconds into QR. QR is how much? From here to here, how much distance is here? QR is equals to P dash. Okay, P dash is how much? 50 meter per second. This is your 50 meter per second. And this second and this second will get cancelled. 5 will go 25 times to 50. This will become 5 into 25 is your 125 meter. So the displacement of the body after 5 seconds is 125 meter, and acceleration of the body is equals to slope of line PQ. So whenever we have to find the acceleration, drop a perpendicular from Q to X axis. So slope PQ will be how much? This upon this. This also QR upon PR. PR 50 minus 0, and PR is how much here? So initially it was 0 second, finally it is 5 second. So this is a 5 minus 0. Acceleration, actually we can use other formula also. It is your change in velocity divided by change in time. The initial velocity is 0, final velocity is 50, so that final velocity minus initial velocity. Here initial time is 0, final time is 5, so that means final time minus initial time. This is equals to 50 divided by 5. This is a meter per second. This is second. 5 1 are 5, 5 10 times. This will give you 10 meter per second. Per second is a per second square. This is the acceleration of the moving body. The next is velocity time graph with uniform retardation. Velocity will be decreasing by equal amount in each interval of time. This is a 10, 20, 30, 40, 50, and this is a y-axis, which is the velocity in meter per second, and time 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. It's a x-axis, it's time in second. Initially, the velocity of the body u is 50 meter per second. If the velocity of the body or moving body is decreasing by equal amount in each second, and then the graph will be like this. In first 1 second, the velocity is decreased by 10. Okay, in second, another 10. Third, another 10. Fourth, another 10. And the fifth, it will reaches here. Distance traveled in first 5 seconds. In first 5 seconds, what is the distance traveled? So distance traveled in first 5 seconds means it is again it's forming a right angle triangle here. Let this be A, this be B, and this be O. So distance traveled in first 5 seconds is the area enclosed between the velocity time scale and the x-axis here. So distance traveled in first 5 seconds is the area of triangle AOB. This is the right angle triangle. Area will be a half into base. Base is a OB into height here is AO. AO. So base OB is how much? Here it's represent, this axis will represent time. So that means 5 seconds 1/2 into 5 seconds into AO is the height. So AO, how much is the height? 0 to 50. This is a 50 meter per second. Second will get cancelled. 2 will go 25 times. This is a 125 meter. Since the velocity of the body is decreasing, we have to find the retardation. Decreasing velocity is retardation, or negative of acceleration is retardation. If we see the graph carefully, we can notice that here the body is moving towards the initial position, towards the starting point. when the body is moving towards the starting point, the graph will represent negative slope or negative velocity. Retardation of the body is equals to negative slope minus slope of line AB. Slope of line AB. So here this is an initial velocity and the final velocity will be here. Okay. And the time is fine. Initial time is 0 second and the final time is 5 second. So here slope of line AB is equals to minus slope. AB is how much here? Slope of line AB can be written as AO divided by OB. It's here AO divided by OB. OB. Here minus AO is how much here? Initial is 50, final is 0. 0 minus 50, this is a meter per second whole divided by, the time is fine. Initial time is 0 second, final time is 5 second. So that means final time minus initial time, this is a second. This will give you minus into minus 50 divided by 5. So this will cancel 5, it will go 10 times and this is a meter per second square. This is equals to minus into minus plus, this will become 10 meter per second square. So the retardation of the body is 10 meter per second.